Yo guys, we are back. In today's video we will talk about the sell functionality for the sniper bot that we created earlier. Because so much people send me like, how can you actually sell these tokens after you snipe them? So if you want to know how we built the sniper bot in the first place, I recommend that you watch the first video. I will put the link in the description. If not, you can also look at this video. I will go over the whole sniper in the overview, and then we will look at how we can sell the tokens in more depth. But again, if you want to know how you do the selling or buying first, you can watch the first video and then come back here. I will also recommend that you stay and watch till the end of the video, because there I will see how the token sniper actually works and also how we added these extra components, and we will also go over a few things that we can improve in the future to make our token sniper even better. So if that sounds interesting, leave a like, and also if you have any questions, put them in the comments and I will do my best to answer them as soon as possible. Alright, so in the first video we made the part where we buy the tokens, and we had this diagram that we always looked back at to see where we were in the code. So I will go over this real quick. I will not show the code for this. If you want to see how that is built, you can look at the previous video, but it will give you a bit more context on how we will actually do the selling. So our sniper bot actually goes and looks on the Solana blockchain using a WebSocket RPC, and we pull some kind of logs which are related to the Raydium program. So whenever a liquidity pool is created, we get these logs and we take the transaction or the signature from that log. With that signature, we actually look up the actual transaction that was created for creating this liquidity pool, and then we get transaction details back, which we will use to extract pool keys from. And with these pool keys, we can go on. So we can also do a rug check. One of these pool keys is the token mint of the token that we're sniping. And if we do this rug check, we get a report back, and this rug check will contain things like if this is a copycat token, how much of the holding is done by the top 10%, all these kind of things. And based on this rug check, we can make some kind of decision if we want to buy this token or not. So if we want to buy the token, we move on and we create a swap transaction. For that, we use the Jupyter V6 swap API, where we can get a quote. Once we get that quote back, we can sign that quote, and we can do that with our own wallet and send back the transaction using the same swap API onto the blockchain. So that's the part of the token sniper that we went over in the first video, where we actually snipe the tokens and buy the tokens as soon as possible. Now, the next part is where we will try to sell the tokens, and this is where we will go over in depth in this video. So once the swap API created the transaction and the transaction was actually confirmed, then we will get back a transaction ID. And with that transaction ID, we will use again a API. And this is the same API as we used before, where we get the transaction details. Earlier, we added a signature into that, but we can also provide it a transaction ID actually. So what we do here, we get back the transaction ID because we created a transaction. It was confirmed that it is on the blockchain. That transaction comes back, and we send it to our API to get more details about this transaction. And details for this transaction is actually the balance or the price. We will get the fee that is paid, and we also will get the metadata of the token. So that is really important, because we want to store all these kind of information in some kind of database, and we will use SQLite 3 for this. This is a database that is just a file in our project. You don't have to set up your own database. It will all be done automatically. So once we store this transaction or this token purchase that we did in our database, then we can actually start tracking it, because that's really important. We need to have a list or a database or whatever you call it with the tokens that we sniped, at what price, how much tokens we have, and how much of a fee we actually paid. Because with that information, we can move on and track these tokens that we have to see when we want to sell them or how much profit we made. So that's what we do here. So the tracker is a separate functionality. So we have our sniper bot, which is constantly running to snipe tokens. And next to that, we have our tracker functionality. And this tracker functionality is just a loop function that will be run every 5 seconds. It will pull our holdings from this database, take the token mints of all the holdings that we have, use the Jupyter price API where we can get the most up-to-date price. The price will be returned to us, and then for the tokens that we have, we will have the actual price. And based on that price that is current and the price that we bought it, we can build some logic on if we want to take profit or if we want to sell for our stop loss. And we can also output to our console like how many profit we made, actually the unrealized P&L that we're currently at, how much is that? So this will be run every 5 seconds. It will check our tokens that we have, take the keys or the mints, check the most up-to-date price, return it to us, and then we will do all our calculations to see if we want to sell it because we are making profit or we are losing money. And we also output it on the screen to get a nice overview of what's going on. Once the stop loss or the take profit is triggered, it will use some kind of functionality in our tracker similar to the swap functionality that we used to buy the token. So that's the overview of the whole token with buying and selling. And in today's video, we will have a look at this part here where we store the token and then track the token and have our logic for selling, taking profit, and of course, doing all the calculations to get this information. Alright, so our bot was using this WebSocket, which we went over in the previous video. And once the token was found, it outputs it, it creates a swap transaction. And this is actually where we left off. Like, hey, the swap quote was received. We're swapping the SOL for the token, and here is the transaction. So this is the next step in our process, and that is where we are at here. This is what we did. This is where we stopped last time. We got the confirmation that we have a valid transaction. So the next step is to actually get these details from this transaction. And that is what we are doing here. And for that, we have a separate function. It's called fetch and save swap details. And what we do is we just provided the transaction ID that we got back earlier from the create swap transaction. So this function is also stored in our transactions.ts file. So if you click on that, it will go there directly. And here we can actually see what happens. So the first thing we are doing is actually preparing our endpoints that we will use in this fetch and save swap details function. And all my endpoints are stored in the environment file. I'm showing you the environment backup file because of course I cannot show the actual file which holds my private key, but here I have all my URIs for the endpoints that I use. And again, you can find all these endpoints in the actual documentation from Jupyter or Helios itself. So back at the transactions, here is where we do the first call. And what we do here is making a call to the transaction URI. And if you go back to the documentation, I have it open for you here. This is the same endpoint that we used to fetch the transactions details once we found a new liquidity pool creation. But we can also use this to get more details about the transaction that we actually did. So if you want to find more information about what it returns, you can come here and see how the request is made and what actual info has been returned. But as you can see, this is just the same functionality that we use here in our script. Only have we the URL is extracted away and the transactions is also coming from the input from the function here. So once we got this information, we check if we received something. If not, we return false. If we did receive something, we move on. And also, if you are interested in how this return payload looks, again, you can use the documentation to see what you get back, but also as we are using TypeScript, everything has types. So you can see that we are expecting a transaction details response array or a swap event details response. And these are stored in types because for all the responses, I create types, and you can have a look on how these payloads look and what information you can extract away from that. So if you want to update your own sniper and you want to get more information, you can actually look at these things, see what you receive, and use other values, but that's up to you. So once we receive the details from this transaction, we have the program info that we extract, the token inputs. So what token did we pay with? In this case, Solana. What did we get out? This is the token that we sniped, the fee that we paid, the slot, when it actually happened, and a short description. And in these inputs and outputs, it will contain more information about the balances and the actual tokens that we received. So next, we want to know the most up-to-date price of Solana. And for that, we can also do a API call. And this call we're doing to a price URL. And this price URL is just a variable for the Jupyter HTTPS price URI. And also this is stored in the environment backup file or the environment file. And if we go back to the documentation, this is the API that we use for that. So to swap the transactions, we use the V6 swap API, but they also have a price API that we can use to get the most up-to-date price. And what we do, we use this endpoint to get the SOL price, which we are currently at. And this is just a GET request where you can provide the ID or the mint of the token, and it will return you the most up-to-date price or the derived price. And you can also provide it with a parameter show extra info, and you will get more information on how this price was created. You can look at the last Jupyter sale at or the last quoted price. So you can use any of these parameters to get the most accurate price possible. So that's what we do here. We get the latest SOL price, because based on this SOL price, we can make some calculations on how much we actually paid per token. And that's what we do next. Here we actually see if we received the SOL price, because that's really important to move on. If we cannot get that price, we return false and nothing happens. But if we have that price, then we can move on and we can see how much SOL we paid in SOL. We can also see how much SOL we paid in USDC. We can also see how much SOL we paid in fee we paid in USDC. And we can also calculate the price we paid per token. And that is just done based on the actual SOL price, the amount of tokens that we got, the amount of fee we paid in SOL, and then times the SOL price, and how much we paid for each token, which is the SOL price and the amount of tokens that we received. Because all this information we need to have in our tracker to make decent calculations on when we want to sell and how much profit or loss we are making. Next, and this is additionally, we also want to get the metadata, because it's nice to output the token mint, but it would also be great to see what the actual token name has, the actual metadata of the token. And for this, we're using also an endpoint. It's the RPC URL, and also this is the same URL that we used before. And if you go to the documentation, it's this endpoint that we're using here, but we're using the get asset method. You can get more information on how to make a request. But again, the thing we want to get out is the actual metadata, which is the name of the token and the symbol, because that we will use to just output it a bit more nicer for us. So we have a better idea of what token we are making profit for and what token we are making a loss for. So that is what we do here. We're getting this information on what the actual name of the token is, or the actual metadata of the token. Once we have all this information, like when it was bought, the token, the mint, the token name, so the metadata, the balance of the token, so how much tokens are we actually holding, how much SOL we paid, This is probably what we said earlier, the 0.01 in our config file, but we also extract it. How much SOL we paid in fees, and then the same in USDC, how much SOL we paid, how much SOL we paid in USDC for fees, and the price per token, the slot and the program ID. This should be Raydium, but if nothing is returned, we just put not available. So we take all this information that we collected here, and then we store it into a constant called no holding or new holding, and then we will store this. So this whole object we will pass in a function called insert holding, and that is where we are now. So if we look at the diagram, this is what we just did. We got this information back, we are collecting all the details for the transaction, and then we will store it into a database, and that is actually here. It's called store procedure, you can call it, or just store the data in this database. So that's what we are going to do here. And for that, we're using a function called insert holding. And if you click on it, you'll see that it will be moving to tracker. And this is a file called database or db.ts. And here we have our logic for the database related things. So as you can see, it says insert holding. And what it does is really easy. It opens the database. So the database is actually stored in our config file again. So if we go there, we have database name tracker holdings. We want to have it in source tracker holdings.database. So that's what it does here. It opens this database and which driver to use. The good thing is, if this database does not exist, this will also create the database for us. So you don't have to think about creating this file. It will all be done automatically. Next, we also want to make sure that we have the table to store the data in. And to do this, we have a separate function, so which we will call, it's called create table holdings, and it's actually above here, which will create the table for us. And if you read here, it says create table if not exists. So if the table exists, it will skip it, it will return true because we have a table. If it doesn't exist, it will create it for us and return true as well. So that's what we're doing here. We're checking if the table exists because we need a table to actually store these tokens. And if all is good, we should have holdings table exist and we can move on. Then the holding object that we earlier passed in this function, which you can go back and look at here, which is new holding. All this information we provide in this insert holding function, which we get here. We extract all these parameters from holding so we can use them into our insert statement. And that's what we do here. We're using the database that we just created or opened, and we are using this query here to insert all this information into our table. And these are just parameters for the information that we will provide here. So as you can see, these are the parameters that we provided. We extract them, and then based on the columns and the question marks, the right order, we can insert it into our holdings table. So that's what we are doing here. And we can also test this because we have a test function written here. So this is just a test transaction. It's from an old token, so I'm not sure what it will output, but we can try it. And we can do that by running npm run test. That's true. You see that our database is actually created here. So that's good. And then we can npm run tracker. And we can see if there is something in our database. You see that we have now a token called NVIDIA with unrealized PNL minus 103%. That's probably because it's an old token. Of course, we didn't snipe it, it's sold before, but you get the point. We have the holdings database created and we have the token in there, which we pulled all the information for. We can just stop the tracker. We can also delete this database because we no longer need it for. So that's what the functionality insert holding does for us. So once the record has been added to the database, we can move on to the next step, because now we collected all the information, we added it into the database. That's what I just showed you. And that is where the job is done for our token sniper. So the next thing we need to do now is build the token tracker, actually. The one we just ran that you showed, the PNL. That is what we are going to do now, because now we have our tokens in our database. And you can run your tracker, or you can run your bot without having to run this, because what it will do is just buy the tokens for you and store them in a database. So you don't have to run the tracker if you don't want to. Alright, so now that we know that our sniped token was successfully, and we also stored it in our database, we can move on with actually tracking it and also sell it whenever it's a stop loss or the take profit. So for that, we have a file called index.ts. I stored it in the tracker folder so that the tracker is separated from the actual token sniper. So the logic is also separated. Well, everything starts by starting this main function, which is calling function main. And the first thing we do is making sure that we have our price URL, which is in this case the Jupyter price API, the same that we used before to get the latest Solana price. We will use this one again to get the latest token price for all our sniped tokens. Then we create again the database, or we open the database connection, and we also create the table again if needed. And this we will only do because in the case that you will start the tracker first before the actual sniper bot. And this is okay to do because it only creates the table if it's not there. If it's there, it will just skip over it. But by doing this, we know that we will actually for sure have a table and a database in place. So if that's the case and both are created and in place, then we can move on. And the first thing we do is creating a constant, like an array, where we can store our logs in. Because for every token that we will iterate over, we will output something like the current PNL, and if we are in positive or in negative. But while we are going over these tokens, we will store them in a constant to then later output them all at once. So they are not coming in separately, but all at once, which will make it look a bit more smooth. And to store these logs into this array, we have a save log function that we can later use, but we will come back to this later. It will make more sense then. So the next thing we need to do is actually get all our holdings from our database. And we do that by going to the database connection that we earlier created. And in that table holdings, we will select everything from that, because star just means everything from holdings. And then if our holdings return something, which is the same as saying the length is not null, then we can continue with our logic to check if the tokens are in profit or are in loss. So the first thing we need to do is take all the holdings and make sure that we get the token mint. And that's what we are doing here, token. Because remember, when we fetched the swap details, or no, we fetched the swap details, we actually stored the token mint under token, and that we inserted in our database as token. So we can go here, and here the insert is under token. So that is what we are looking at here. So from all these holdings, we want holding token, and we will join all these tokens in a variable called token values, and we separate them by a comma. So what you will get is something like token mint, comma token mint 2, comma token mint 3. So that is what this will output. If we only have one token, then of course it will be only one token mint. But we need that to actually make our next call. And what we will do next is making an API call to get the latest token prices from these tokens that are in our database. Now, to do that, we have something called a price API, and it's the same one that we used before, but then we only use it for Solana tokens, for the Solana price. But what you can do, and I can show you here in Postman, is you can actually request multiple prices for multiple tokens if you just add a comma here and add the next token. So, for example, if we want to also get the Sol price, then we can do here a comma Sol. And if we send this to this price API, and I will just remove this show extra info so it makes more sense, then you see that we get back the token that we requested and the Sol price. And that is why we in our logic make all these tokens separated by comma into one string, because then we can request it really easy at this price API and we get it back in a structured way. So we can just go and check for each token what the current price is. So that is what we are doing here. So we are actually getting all these tokens, all these mints in one string. So we can easily insert them in the parameters, and we also append the Sol. So we also get the latest price from Sol back. And also that is, again, we saw it before, but it's documented here as well. You can add multiple tokens and again the show extra info for more information. So once we get the current prices, we also check them, of course, because these current prices we need to do calculations for our unrealized P&L and to see if we are making like gains or if we are losing money. So that's what we are doing here. We're also checking for sure that we have the prices returned. So then, if we have the current prices for all the tokens that are in our database, then we also have to loop over all the tokens in that database, but we already have the holdings because we already selected them. We don't have to select them again. But what we will do next is we will loop over all of them and get all the information out of that row that we are looking at, because mapping will just go over all the tokens that are in these holdings that are returned. So if it's 2 holdings, 3 holdings, we will map over each holding one by one, and we will store that in a row. Row in this case is the current token that we're looking at, and then we can get all the information for that row or for that token, and we can move on with doing some calculations. So the first thing that we do here is making the time that we actually bought the token a bit more human readable, and we do that by using a datetime formula. This is also a package that we use. It's called Luxon. You can look it up. Just type in Google Luxon or npmi Luxon, and you can get more information. But this package just helps us make the time look more human readable. Next, we want to see what the current price is for this token. And our current prices we received here because we requested them. And remember, they are returned in this format. So token mint and then the information. So what we do here is token current price, so current prices, token mint, in this case, the token that we are looking at. And then we are going extra info, last swapped price, last Jupiter sell price. And this is the current price that we will base our calculations on. However, as you saw here, we can use a show extra info. There is a lot of different prices that you can base on. Like, do you want to use the last Jupiter price, the last quoted price? All of these prices, they can look different because sometimes they are. And that's one of the improvements that we can make for this bot to make sure that we get the most accurate price. But most of the time, the price is quite accurate. So that's what we are doing here. We are extracting the price from that returned price constant for this token. So now that we have the current price for this token, we can actually calculate things like our unrealized P&L, unrealized P&L percentage. And we just do that by taking the current price minus the price that we paid, and then times the amount of tokens that we have and also the fee that we paid. And that is equals to our unrealized P&L. And we do the same for percentage, but there the formula looks a bit different. And also we create an icon, and based on our P&L, if it's positive, we give a green icon. If it's negative, a red. So that in our console log, we can easily see which tokens are positive and which are negative. So that's just the tracking part. So if you look at that, that's what we are doing here. So we take our database, we take our holdings, all the holdings that we have, we send these holdings, the mints in this case, in one string to the Jupyter price API. We get back the current price, and from this current price, we take the token mint that we are looking at, and then we have the current price. And of course, we have our holdings and the current price, and we will all log this out. And the next step is what we are going to do now, is looking at the stop loss and the take profit logic. That's where we are here. Check stop loss, take profit. And we initialize a message that we can use later, but for now it's 0 or empty because we didn't take any profit or stop loss yet. So the first thing we need to check is, did our config allow us to sell? Because we have an option in config. And if you look here, there is a thing called auto sell. And if this is false, we will never sell the tokens. We will just track them. So if we want to sell them, then we need to set this to true, and also set a stop loss percentage and a take profit percentage. So these are important if we want to sell. And of course, you need to find the right balance on when you want to take profit and when you want to sell your stop loss, because a lot of these tokens, they will go up and down really quick. And you don't want to sell too early, but you also don't want to sell too late. But that is the auto sell function that we are looking at here. All right, so if we did set this to true and we want to check for the stop loss and the take profit, the first thing we need to do is make sure that our token balance is like in the right format, because we will check how many tokens we have and we want to read it in. For example, I have 75,000 tokens, but the way we will send this to the swap API needs to be in one string without dots. And I can show you what I mean, because I have an example transaction here from the token love in this case, where we buy 29,000 love tokens. And we do that, if we can look for the amount in, we do that for 0.01 sol. But remember, this is in Lamports, and this is the way that we need to provide it. So if we sell that same token, the 29,000 tokens for sol, the same thing needs to be done. We need to provide that in the same format. So it's in one string without the dot. And you can see it here, it's the discriminator, it's set to 9. And that's why we are using this whole string without the dots. So we cannot just send it to the swap API saying 29,488 dots. So it needs to be one string. So that's what we are doing here. We just replace the dot with with nothing. So we get actually one string. But that's also why we need to make sure that we get the token balance in the whole way with all its floating point numbers, or what's it called, I'm not sure, with all the things behind the dot, so that we later can actually translate it into one string. And that's really important, so that we make sure we take the right amount of profit. I think also if we provide the dot, it will not really work, but we need to really do this. It's really important to move on. So then next, we check our unrealized P&L. If it's bigger than the take profit that we set, we will sell. Or if it's smaller, in this case, or equal to our stop loss percent, then we will also sell. And remember, these are set in config, where we set stop loss 100% loss, we sell, of course, and take profit 50% profit, we sell. Now, again, you need to find the right balance for yourself, but that are the values that we use in here to continue with a sell or not. So if any of these two hit, the same thing happens. We want to make a sell. It doesn't matter if it's a stop loss sell or a take profit sell. We just want to sell all our tokens. And for that, we have a create sell transaction function here where we provided the Sol mint, because we need to swap against Sol, our token mint, and the amount in. And again, this function is in the transactions file, and it's quite similar to the function that we used to use to create a swap transaction when buying the token. And in an ideal world, we would use the same functionality and we will extract some more logic away from it so that we don't have to use duplicate code. But for simplicity, I'm using two different functions, so it makes more sense. So this functionality will takes in Sol mint, token mint, and amount. And here we will do the exact same thing as what we did while creating the swap transaction, but we will do it the other way around. We will request a quote where we provide our token mints. This time it's the token mint. The input mint is the token and the output mint is the Sol. It's exactly the other way around than when we swap the token, when we snipe it. The amount, and then we also have slippage, and I have a different slippage parameter for swapping in and selling the tokens. So here you can also set slippage for selling. So prio level, slippage, and also the max lamports that we use to do the swap. We have the exact same things for swap here when we buy it, but you can specify different values if you want to sell it. So once we have our quote, we will send that quote again to the swap API, and that swap API will send us a serialized transaction, which we in case can sign with our wallet. But this is the exact same logic that we used when we sniped the token. And we check the latest block hash, which we will need to confirm our transaction later. But here we will send the transaction that was signed. And we see if we received a transaction ID. And then we will ask for the confirmation based on this transaction ID. And if no error returned, we move on. If an error returned, then we will return null. And I will show you in a minute how we handle that. But if nothing returned or nothing bad returned, we will do remove holding so that we don't track this token later again. And this is also a function that we use in the database file here in our tracker. And we just provide the mint. And what it will do is remove the token from our database. This is the same logic as the insert. We check if we have a database and we open it, and we should already have a table, otherwise we cannot delete it from it. So that step we skip. And here we just say delete from holdings this token. So that's all it does. And then we move on and we return the transaction ID. So all this logic for selling our token is the exact same logic as we used for swapping the transactions. So if you want more information on that, you can also refer back to the first video, but you can also go back to the Jupyter documentation, and this is where the price API is. They also have the V6 swap API, and this has all the instructions on how you can make a swap transaction for selling and buying. And these are the exact same logic that we use in our script, where we initiate the wallet. We get the quote response. That's what we are doing here. We are requesting the quote. Then we get the serialized transactions to perform the swap. All these instructions are the same as what we are providing here. And then we deserialize it, execute the transaction, and we move on with confirming it, because all these code snippets, they are just copied and just changed a bit based on the config parameters that we have. But if you read through this documentation, you will be able to set up a swap transaction really easy. And it also says here, the Jupyter APIs are the easiest way for developers to access liquidity on Solana. And by using the swap API, you can easily swap tokens. So it's really straightforward. Just read through it and it will make more sense. So in case we return null, if we did not swap or we did not sell, then of course it will not be deleted from our database. And then here in our index, where we ask for, no, not in this index, here in this index from the tracker, where we ask to do the sell, if it doesn't return anything, we will output also could not take profit, trying again in 5 seconds, or could not sell, stop loss, trying again in 5 seconds. And that message will just be appended. And here we will save that log. That's where I was talking about earlier, where we use this functionality, the save log, where we put in our log and we say trade time, token balance. We bought so much of this token for so much USDC. And this is our PNL icon, and this is our unrealized PNL. And we also append a message if we could not sell our stop loss or take profit. And then we save this into our holdings logs, and we move on to the next token. So once all the tokens are handled, then we can move on. And what we do here is clearing the console. And then we log out all our holding logs, the ones we stored into this, and we create a new line for every token. So they will always be shown at the same time, and we clear the console. So it makes it look more nice. And here we just say if there is no holdings, then we output this. So we also know that the tracker is actually working and that it's updating. So that's the whole tracker and the take profit and sell stop loss functionality. And we have an additional check here, public wallet, which you can add for yourself if you want to in the config. If you track public wallet, if you add your public address here, the only thing it will do is create a link at the end of the output where you can click on and also check your wallet on another website, in this case GMGN. And then we close the database. And once we did all this, we set a timeout for 5 seconds, and this is in milliseconds, to call this main function once again, and we will repeat the whole process. So every 5 seconds, we have an updated PNL for our tracked tokens, and we will also check if we will sell or take profit. And you can increase this, but you have to take in account that you can run into rate limits with APIs. So I think 5 seconds is quite good. So that's the logic for taking profits, selling of stop loss, tracking the tokens you have. And the next thing we need to do is actually start this thing up and see if it actually works. All right, before we start this bot up, the tracker and the Sniper, I want to go over some considerations real quick and things on how we can improve this bot. So I listed them down here. I wrote to do. So one of the things we can test is by adding this bot into a cloud instance, which is located closer to the actual physical location of our RPC nodes. And if you look at the locations for example, Helios, they say that Helios provides services through a globally distributed network of nodes. And the key locations are New York, Ashburn, Chicago, Vancouver, and so on. So we can set up a cloud instance in a region that is really close to these locations. So then you can also try to minimize the latency between you and the RPC nodes. Another thing we can test is other RPC nodes from other providers, both free and paid. For example, QuickNode and Shift are also providers for Solana RPC nodes. You can expect to be better performance with a paid node, of course, but you need to test them with free alternatives from QuickNode and Shift. So next thing that I wrote down here is to improve this bot is verify if the tokens are still held by the holder, because you can snipe them, store them into your database, but what if you go outside your sniper and you sell them? Then of course the tracker will see the token, it's still in there, try to sell it, and you will get some kind of error. But for this you can use a get access by owner or get assets by owner endpoint, also from Alias. And here it says how you can actually request the tokens held by a certain owner for a certain wallet, and then you will get back all the tokens. And it also has the amount that it holds. So if that in that case is 0, then you know that you can also build some logic to remove the token from your database. So that's something that we should implement to make this tracker even better. And the next thing here is add more sources to get the current prices, because as you saw in the video, we use the price API from Jupyter, and this only replies with prices based on the last Jupyter sell at or the last quoted price. And of course, it also has the price based on what Jupyter has. But we should be able to add more resources or more sources better to check the current price or get a more accurate price. As I said, the price is quite accurate as far as I can see, but adding more sources for getting better prices could also improve this bot. So these are some considerations that you can think of, that you can keep in mind when building a bot, because making a bot like this is not that straightforward always. You need to think of all these small things to make it faster, to make it more reliable. But these things are a good start to look forward to on how we can improve the bot. So with that being said, let's start it up and see if we can snipe some tokens and maybe sell them for some profit or maybe a loss. Who knows? But that's it. Alright, so to start both of them, you just need to open 2 instances of a terminal. And to start the sniper, you can just run npm run dev. And to start the tracker, you can just run npm run tracker. And both of these commands are stored in the package.json file. So if you look in here, we created these commands so you don't always have to type in this whole string of text. You can just use npm to start the dev and the tracker. So by knowing that, you can go back and start both of them up like this, and they can run, they can actually run next to each other, so that's no problem. You can run the sniper without the tracker. Of course, you can also run the tracker without the sniper, but nothing will come in. So the moment the token comes in and we buy it, I will come back to you, and then we can have a look together and see if we get some profit or not. Alright, so we found a potential token now, so let's see. If the swap is actually successful, it should show up in our tracker here. So the swap was successful and our tracker should pick this up any moment now. So there it goes. And I did auto sell. I put it on false because of just to showcase how the tracker picks it up. And also continues to snipe new tokens. And my rug check is also not that strict, because I wanted to pull in some tokens real quick and see how it actually shows us the information here in the tracker. So we found another token, and if we can swap this one as well, it should pop here in the tracker first as well. So as you can see, now we're tracking 2 tokens called Lucky Llama and Santa's Gaiat or something like that. And you can see the actual PNL that we are getting back. Of course, because our rug check was not that strict, I am quite sure that these are like rug check tokens. But for the sake of the demo, we can keep following it and see if any of them turn green. So eventually one token is turning green or into profit, and we can also have a look here. These are the 2 tokens that we're holding. So again, these prices are fluctuating quite a lot. So it's already red again. So that's why we have the auto sell on. So the moment it hits our target and the tokens are a bit better, it should sell straight away. And here we have another token coming in called Frog Pepe or something like that. And it's already at minus 104. So these are for sure rug pulls happening all over the place. But that's our own fault since we have a bad rug check in place. And we're also tracking rug pump tokens now, or Pump.fun tokens. But that's it. That's how the tracker and the sniper works.